So now that we've examined some of the basic terms and ideas of probability, let's discuss relative frequency and how it applies to probability and the law of large numbers. And so let's start with the formula for relative frequency. You might notice that it looks very similar to the formula for probability. The formula for probability says the number of desired outcomes over all possible outcomes, whereas relative frequency says n of x, which is the number of events with that outcome, divided by the total number of events n. And so what's the difference between these two formulas? Well, probability is talking about theoretical probability of what might happen out of all the possible outcomes, whereas relative frequency is talking about what actually happens if you perform this experiment multiple times. And so to sort of explain this idea, let's perform this experiment multiple times. Let's draw and replace marbles 10 times. And if we do, what would be the relative frequency of drawing a green marble? And if you notice, they write relative frequency of outcome x as f of x, and so we'll do something similar. We'll say the relative frequency of outcome g is f of g. Now, based on our probability for g, or p of g, that we discussed in our last video, where we got 20% or 0.2, we should expect our frequency of drawing the green marble to be 2 out of 10 of the times we draw, because 2 is 1/5 of 10. But when you actually perform these experiments, these numbers can get a little messy. In the same way that if I flip a coin 2 times, you would expect one time to be heads and one time to be tails, but it's possible to get 2 heads in a row. So let's write out the number of each color we might see drawn if we did this experiment 10 times. And so maybe on the first time we reach our hand and we pull out a random marble, and the first time it's red. And then we replace it and we draw again, and maybe the second time we draw a blue marble. And then we replace it and we do it again. And maybe on the third time we draw a yellow, and then we replace it and we do it again. And maybe on the fourth we draw green. And then who knows, maybe we draw green again on the 5th time. And then maybe we draw blue 2 times in a row as well. And we haven't drawn purple yet. And how many times have we drawn so far? So we got 1, 2, 3, 4, 5, 6, 7. And actually, let's not draw purple. Let's pretend like purple's way down there and we just happen to not draw it once out of 10 times. And so maybe on the 8th time we draw red again, and on the 9th time we draw green again, and on the 10th time we draw blue again. And so out of 10 times we drew blue 4 times, out of 10 times we drew purple 0 times, we drew green 3, we drew yellow only 1 time, and we drew red 2 times. And so what was the frequency of the amount of times we drew our green marble? What was our relative frequency? Well, the total number of events goes on bottom, and that was 10. And the number of times we got our outcome G was 3 times. And so our relative frequency was just 3 over 10, or 0.3. And so what does that mean? Well, in this hypothetical situation, 30% of the time we got green. Well, that's significantly different than the expected 20% that we should have got. I wonder what would happen if we changed the situation to perform the experiment 100 times. So draw and replace 100 times. What would happen to our relative frequency of green then? And we should probably add a question mark to this. And oh, I just noticed that I didn't add a question mark to this one, so we can go back and do that real quick. Well, based on our theoretical probability, P of G, which is still 20% or 0.2, we should expect our frequency to be 20 times out of 100. And so let's compare that to our hypothetical table. And actually, let me just go ahead and copy and paste this real quick. Let me see if I can do that without getting those dots in there. And don't worry, I'm not going to perform this experiment hypothetically 100 times. But what numbers might you expect to see? Well, in all honesty, you should expect to see around 20 for each number. And so maybe you get exactly 20 for red if you draw 100 times. And maybe you get a little bit less. Maybe you get 19 for yellow, close to 20, but not exact, because when you're dealing with real numbers, things tend to get a little messy. And maybe we get a little over 20 for green, and maybe we get a little over 20 for blue. And so what does that leave us with? What would we have to get for purple to make these numbers true? And so 19 plus 21 is 40, plus 20 is 60, plus 22 is 82. So what we have left is 18, so a little bit less than 20. And if you think about it, these numbers make sense. You might not expect to get exactly 20, but you should expect to get within 3 or 4 of 20 for each individual color. And so what is our relative frequency for the green marble in this situation? Well, the number of total events this time is 100, and the amount of times we got green, in this case, was 21. And so 21 over 100 would be 0.21, which is much closer to 0.2 than our relative frequency was when we performed the experiment 10 times. And of course, hopefully this makes sense that this number would be closer. In order to get 0.3 over here, we would have had to draw the green marble 30 times, which is much less likely. Just like it's much less likely to draw our purple marble 0 times out of 100 than it was to draw our purple marble 0 times out of 10. This seems possible, but over here it would be very unlikely. And so the point I'm trying to make can be summed up by the term the law of large numbers. And what the law of large numbers states is the more times you repeat an experiment, the closer the relative frequency tends to get to the true probability. So if I were to perform this experiment 1,000 times, we would expect the relative frequency to be even closer to our probability. And the more times I repeat an experiment, the more I would expect it to reflect the actual calculated probability.